Hello, everybody. First, I thank everybody for joining us today, and I welcome you all for this workshop. My name is Srinivas, and I am joined by my two colleagues, Madhusudan and Nagraj, who are our experts on our test solutions. In the first workshop on our radio emulator, we learned how simple and easy it is to simulate AZ call scenarios as per ED137C version. We also showed how PacketScan can be used to monitor and analyze air to ground calls in the network. And oh, we also verified like how the voice quality metrics like MOS, packet loss, jitter, and delay. Okay. So today we learn about simulating ground-to-ground calls using our MAPS ED137 telephone, and we'll also use PacketScan to monitor these calls. So I'll begin with a small presentation on MAPS ED137 telephone and PacketScan. Then we'll move on to the live demo. First one to go is MAPS ED137 telephone emulator. It is built on our generic framework MAPS, which is used to simulate protocols across different technologies like TDM, VoIP, 2G, 3G, and LTE networks. MAP stands for Message Automation and Protocol Simulation. And as the name suggests, it provides complete flexibility to simulate complete protocol state machine. We can also design custom call scenarios and custom messages also. So telephone emulator is a lightweight software with easy to use graphical interface, and it runs on Windows platform, Windows 7 and above. It provides a flexible architecture for custom testing scenarios. So as you can see in this diagram, MAPS ED137 telephone is used to simulate ground-to-ground calls. It supports both ED137B and C versions. So the ED137C version is introduced recently. It can simulate hundreds of CWPs in a single instance. Each can have a unique IP address also. It can be used during development stage or functionality testing, or for field testing, and also for commissioning the products of the network. It can also generate bulk calls using multiple CWPs to conduct performance testing on a device or network under test. And supported codecs include ELO, ULO, and G729. And we can also perform different traffic actions on the call. For example, we can send and record pre-recorded voice files, send and detect the digits and tones, and we can also talk using the microphone and play the incoming audio using speaker. So in this slide, you see like different call types as defined by the ED137 specifications. So these are the basic 8 calls, and C has also introduced some other calls, specifically more related to conference calls and all. So you can see here for every call we are providing the call graph, so that it indicates like what exactly the messages are exchanged on that call. So in this diagram, you can see that we have configured 10 CWP profiles. So each profile will have its own set of call parameters. So basically these call parameters include like the SIP URIs, like a contact address, address of record, and SIP URL to whom we are going to place the call, the other end party. And also there are some ED137 parameters like to indicate the subject, like what type of call it is, call priorities, version, call types, and so on. Okay, so you can see here, multiple controllers can be created in a single instance of maps. So all of these CWPs can be used to place the calls either simultaneously or based upon the choices. Okay, and it also supports different call scenarios like call hold, call transfer, basically like attended, unattended, and other call scenarios. And we can also reject create some negative call scenarios also by rejecting the calls with different SIP errors, for example 4xx, 5xx, and 6xx, so that we can see how the device under test is going to behave when these errors are being generated. Okay. And we can also introduce impairments on the generated RTP traffic. Basically, these impairments can be packet loss, latency, or out of order and duplicate packets. So this is the basic call generation window. So you can see here under the script name, the default script that we provide is the SIP call control.gls, and it handles the complete protocol state machine. It can handle all the call scenarios. Okay. And under the profile, we can select the CWP using which we want to place the call, and the call info will provide the other end entity to whom the call is placed. And this is the start script execution button. And as and when there is a status update on the call, the status column is going to display the current status. And there will be some events button which will allow to perform certain actions like to transfer the call or hold the call. Okay. And there is a result column which we can display like whether the test case is passed or failed. So this results or the conditions can be defined in the script by the user as per his requirement. Okay. And we can so below here we are displaying the complete call graph. Okay. And if you select on a particular message, we are also providing this message decode where it shows the complete SIP message. Okay. And for the automation purpose, we have provided features like we can run multiple scripts simultaneously, either in a sequential manner or in a random way. And we can also define how many number of times we want to run these test cases also. So you can see here we have defined 5 iterations, and it shows the completed iterations count also. Okay. So apart from this, we also provide the automated scripts for certain actions. Okay. And we also have a feature called scheduler, which can help in running a set of scripts at a different at a defined interval or at a specified time for a specified number of times. And next one here, pictorially we are showing that how multiple CWPs can be created within a single instance of MAP CD137 telephone. So other side could be devices under test. Okay. And we can generate a different call scenarios. These are the telephone call scenarios. So that is a brief about the MAP CD137 telephone simulator. Now we'll move on to the PacketScan. So PacketScan is basically a non-intrusive traffic monitoring tool, IP traffic monitoring tool. So it can be used to monitor and analyze both air to ground and ground to ground calls. So again, it is a software only product, and it can run on the Windows platform. Okay. And it can also read or write to Wireshark trace formats like PCAP or PCAP-NG files. So this is the main window of PacketScan. So there are two sections here. The first one gives the complete frame summary. So you can see here it indicates the SIP method, caller, callee information, and all the IP address and port numbers involved. And below we have a complete frame decode right from the MAC layer till to the end of the application layer. And we also decode all the ED137 extended feature specific header extensions. And apart from this, we can also apply the capture filters so that we can capture only the traffic of interest. So this next window shows this is the call summary view where it will list out all the captured calls. Okay, you can see here the red color one will indicate the signaling information like who is the caller and callee, and the other two black lines will indicate the incoming and outgoing traffic. And you can see here we are providing all the details for the traffic, like what is the codec used, number of RTP packets received and sent, and we are providing for both direction, we are providing the MOS scores, packet loss, duplicate packets, out of sequence, delay, jitter. So we perform the complete analysis and provide all the possible statistics on the calls. So you can also see here some of the calls have a very bad MOS scores. MOS score is around 2.21. So if you look at the reason for this one, so this call has encountered some packet loss. So there are 396 packets have been lost. So the MOS score has degraded. So again, we provide the call graph and message decodes also here. Okay. And apart from this, there are a lot of other advantages, like it can record the audio on the call, or it can write to the wave file, whatever the audio received on the call, and we can detect digits and tones. And we can also have a detailed view of a particular call, wherein it will show the complete packets received, and it will also show the packet by packet jitter, delay statistics. And apart from that, we have an option called triggers and actions, which will help in automated test. So wherein you can do a non-intrusive monitoring without any user intervention. Like you can define the criteria, like I want to filter out the calls with low MOS scores, or calls with from a particular user agent, something like this. So on the filter calls, specific actions can be performed. For example, you may want to save the trace of a call with a low MOS score, okay, or you may want to record the audio on that call. So even those things can be defined. And apart from this, PacketScan can also act as a probe, wherein it will send the call detail records to a centralized database, and from there we can use our net server web for centralized monitoring of the complete network. And even multiple probes can feed data to the centralized database. So that concludes the brief. Now in this slide, I'm trying to show my workshop setup here for the live demo. So I'm using I'm accessing two systems, 12.101 and 12.106. One is acting as a call generator or side A, and other one is acting as a side B, call for the call reception. And I'm going to simulate multiple controller working position in each of these instances. And yeah, I'm going to access these two systems using the Windows Remote Desktop Manager. Okay, so now we'll move on to the live demonstration. So I'll invoke the applications first. So as you can see here, I have taken access of two systems, CWP 101 as a calling party and CWP 106. Okay. So I will invoke the packet scan first. In 101 system, I'll be running the packet scan to capture all the calls, whatever I'm going to generate during this workshop. So I'll just select the interface here, 12.101. So the capture filters, I have defined selected SIP and RTP here. Let's start the real-time capture. And I will also open the call summary view here. So this is the maps ED. Now I'm going to invoke maps ED137 telephone. So before invoking, let me explain this. So when we invoke, okay, it is going to ask for the protocol version. Okay, so you can see here we support both ED137B and C version. Okay, so right now I'll select this C version. Click on OK. Okay. Now the first step is to create the controller working positions. Go to profile editor. Okay. So when you open the profile editor, there will be some default CWPs created. Okay. So now for this workshop, I have done some pre-configurations. Okay. To create the other CWPs, additional CWPs, you can just click on the insert button here. So give a name, CWP 11. Okay, so when you say okay, so the 11th one will be created, and it will just copy all the parameters from the previous one, but you can go ahead, you can change these parameters. Okay, so I have created 10 CWP profiles here. So if you look at the profile parameters, you can see it supports both IPv4 and V6, and we can apply differentiated service code points also. And the call parameters include basically like UDP or TCP transport for the SIP, and we need to specify contact address, address of record. These are the SIP URLs of the caller and callee. Okay, and if there is any proxy in between, we can specify that proxy address also. These are the RTP parameters, like what is the IP address and port numbers used for the media, the packetization time, and followed by some of the ED137 parameters. For example, subject, under subject we have listed all the different call types of telephone. Okay, so you can see here voice call, override call, DA call. So the next one is a priority. So priority can be either emergency, urgent, normal, or non-urgent. WG67 version, since we are emulating C version, so it will be phone.02 by default. But to perform certain tests, we can also set it to different values here. And next one is the WG67 call type. So here also it is going to indicate what is the call type: DA call, multi-destination DA call, monitoring calls, IA calls, and all. Okay. And we have a permitted users list also. So if we enable this one and if we define certain users, the calls will be allowed only from those users. And this is the ease member enable or disable option. So we can send the subscription with ease member to the focus, so that it will be registered with the focus as a called party. And these are the SIP authentication parameters. And there are some call rejection parameters, like as I told, we can forcibly generate the 4xx, 5xx, or 6xx error codes. So we can select those error codes also here. And next section is about codec and traffic configurations. So supported codecs include ELA, EULA, G729, and traffic actions. So it can be file. So in case of file, we'll be sending a pre-recorded voice file. We can generate digit tones, or we can talk using the microphone connected to the system. Okay. So similarly, each of these CWPs will have its own parameters. So right now CWP001, I have configured it for a routine DA-IDA call, and CWP02 is configured for an priority DA-IDA call, and 3 is configured for the monitoring call. Okay. And 4 is configured for the single destination voice call. Okay. The same At the same point, we have also placing the calls to different CWPs at the other end system. So the fifth one is again a DA-IDA call. From fifth onwards, all the other CWPs are configured for DA-IDA call. Okay. Now the profiles have been created. Now I'll save this configuration and go back, and I'll start the testbed setup. So now one side CWPs are ready to either generate or receive the calls. I will go to the other system, CWP 106, invoke telephone here. So select the C version. So here also, first we need to configure the CWP profiles. So I have done some pre-configuration from 11 to 20, and appropriate IP addresses and CP URLs have been configured. Now I'll start the test bed here. Now this side B is also ready to place and receive the calls. So I'll go back to 101, and I'll start placing the calls. So I have opened the call reception window on the B side. So on the A side, I will open the call generation window. Okay. So as I told, this call generation window will we can add an entries here. Okay. So say for example, I'll just make 5 entries here, and for each of them I can select the pre-configured CWPs. I can choose the CWP whatever I have configured. So first one, second. So each of these individual CWPs are configured to place different kind of telephone calls. Okay. So I'll establish the first call. Okay, sorry. 1 second. The other end, W6 global configurations. Yeah, we have a feature called wherein we can auto answer all the incoming calls. So I had enabled that one. Now I'll disable that one, because DIDA call needs to be answered manually. I'll go back and place the DIDA call. So you can see here the call is generated and it indicates the version number and also the call type DIDA call. And I'll go to the other end. So you can see here it is indicating that incoming call is there. It's ringing. I'll click on the accept call to answer that call. So you can see here the call is established, and we also display the call setup time. That is the measurement of the time when the invite is generated and when we get this 180 ringing message. Okay, so that statistics is available. So to look into this invite, so if you go to the click on the invite, you can see here the ED137 headers included for the DIDA call with priority as a normal and the call type as a phone 02 DIDA call. And below will be the parameters, SDP parameters. So the currently it is using the EULA here. Okay. Now we'll do some traffic actions on this call. So this call is configured to send a pre-recorded voice file. So select this call and click on send traffic here. Okay. So it is being, it is generating the sending the file, send file started. So go back to the other end. So we can hear the incoming traffic here. Click on the speaker on.
Flight by 336, good evening. Identified on departure, climb and maintain level 300, climb left heading 240.
Heading 240 degrees in the climb.
So you can hear that voice file being transmitted from the other end. Now we'll demonstrate the other scenarios. For example, as defined in the FAA test scenarios. So this is like a simple routine DIDA call. Okay. So we should be able to make a DIDA call, and we can also cancel this call before it is being answered by the other end. So to cancel that one, you just click on this top. Okay. So you can see here the call is cancelled from the call generator itself. Okay. So so I'll place one more call. Okay. So I'll just show you the scenario where I can forcefully reject this call. So I'll just right click on this one and I'll send some 4xx rejection message, whatever it is was configured using in the profile. So you can see here I had configured for 420 bad extension. Okay, so the 4xx message reply was sent and that is acknowledged by the other end. So the call got failed here. Okay. So similarly, now I'll go and place a priority DIDA call. So that was configured for the CWP 002. So in case of priority DIDA call, the call needs to be answered automatically. So you can see here the call is answered immediately and the call setup time was 14 milliseconds. So if you look at the headers here, it indicates the priority as emergency here. Okay, so that indicates that it's an priority DIDA call. Next one is a monitoring call. CWP03 is configured for a monitoring call. So you can see here this call is also auto answered and it indicates the call type as monitoring. So in case of monitoring calls, the SDP attribute will be set to receive only and the other end is set to send only. Okay. So yeah, we have done some pre-configuration at the other end to give the effect of it is monitoring the call at the other end.
And GT call. This is AG and GT call. This is AG and GT call.
So this is like whenever a monitoring call is placed to the other end. So from the other end to simulate this AZ mixing of AZ and GZ call, we are playing a file, pre-recorded voice file that I was playing at the call generation end. Okay. Now we'll go for the fourth call. This is configured for the single destination voice call. So I'll place this call. This also will get answered automatically. And if you look at the invite here, so it indicates that it is a voice call. And it also indicates that initially it is a simplex traffic. I mean, it is configured for a send only, and at the other end it is like a receive only. Okay, so the other end, I can select this other end and just click on the re-invite to make it as a duplex call. So when I clicked on the re-invite, so invite is sent with SDP attribute send and receive. So now we can send and receive voice from both directions. So next one, I can just clear up some of these calls here. Okay. So I can terminate call from the any end, either side A or side B. Okay. Now I'll go to the call generation side. Okay. I'll place one DA call to demonstrate the call hold scenario and answer this call, accept the call. So once call is accepted, I can put this call on hold. For that, I just need to select this call and click on hold button here. Okay, so you can see here invite is generated and the SDP attribute is changed to send only. The other end is marked to receive only. Okay. So this is the call hold scenario, and at any point of time I can go for a off hold to return back to this call. So now it is send receive, and both side it is send receive. So next I will demonstrate the call transfer feature. So basically there are two types of call transfers. One is attended and another one is unattended. So first I will demonstrate this unattended call transfer. So here the CWP 005U is going to place call to the other end CWP 15. Okay, so in the profile actually, so this CWP 15 is configured to transfer the call to CWP 16 here. Okay, so the initial call will be made between CWP 5 to CWP 15, and then at some stage CWP 15 will transfer this call to CWP 16. And the first one I'm going to demonstrate is unattended call transfer. Establish the call and answer the call at reception end. Okay. Now I can transfer this call. Just right click on the events button. Okay. Click on the unattended call transfer here. Okay. So you can see here this CWP 15 has sent a refer asking the CWP 05 to place call to the CWP 16. So this is a refer to header, and this is a referred by. In the refer to, it is CWP 16, referred by CWP 15 here. So you can immediately see here the next call has also popped up. So we can answer this call. Okay, the call is established now to the CWP 16 here. The caller is same CWP 005. Okay, We'll go back to the previous call. So you can see here the refer has been sent. It is acknowledged by 202 accepted, and then there is a notification has been sent saying that subscription state active, and it is subscribed for the refer event. Okay, there's a 200 okay. The initial call is terminated, and once the new call is established, it again sends a notification saying that I mean CWP 05 sends a notification indicating that it is terminated now because of no resource available. Okay. So this is about unattended call transfer. Now we will now I'll demonstrate the attended call transfer. I'll go back to CWP 01, place the DA IDA call again. Okay, go to the call reception, accept the initial call. Okay, now right click under the events button and click on the attended call transfer. So you can see here, here CWP 5 makes calls to 15, and 15 actually puts the call with 5 on hold and makes a new call to the 16. So that call I'm going to accept the call. Okay, so as soon as I accept the call, CWP 15 will refer that call to the will indicate a refer call to CWP 5 saying that now you can establish a call to the CWP 16. So this is the third leg where I'll accept this call. Okay, so this call, as soon as this call is accepted, the other two previous calls, that is between CWP 05 to 15 and CWP 15 to 16 will get terminated. So if we, so finally the call is active between CWP 15 and 16 here. Sorry, CWP 05 to CWP 16 here. Okay, and if you look at the initial calls, so you can see here. So initial call was with send receive actually. Okay, and when attended call transfer is attempted, it will put this call on hold. Okay, and it will make a fresh call to the CWP 16 to check its availability, and then it will put that call also on hold. Okay, so it has put this call on CWP 15 to 16, this call also on hold, and then it is going to refer the call to 16. It will inform CWP 05 that the call needs to be transferred to CWP 16. So the usual refer and notify messages will follow, and the call between CWP 5 and 15 and also between 15 and 16 are terminated, and finally we are left out with the active call between CWP 05 and CWP 16. Okay, so these are some of the scenarios, and there are many other scenarios like SD voice calls and other conference calls also. And yeah, now we'll demonstrate the, we will move on and demonstrate the bulk call scenarios here. And to make the bulk call scenarios, actually I'll just in the global configuration I'll make a setting to answer all the incoming calls as auto answer, so that as soon as I start placing the bulk calls, they get auto answered. Otherwise, manual operation will be difficult to answer all the multiple calls at the same time. Okay, so I'll save this one, go back to CWP 01, and before that, okay, this is the call generation, bulk call generation window. Okay, so here we are configuring the total calls to be generated. If it is a star, means it indicates that there is no limit. The calls need to be repeatedly placed for the infinite time. Maximum active calls indicate that at any point of time there should be at least 25 active calls. And we have some different distribution mechanisms like fixed, uniform, ramp distributions. And call rate is how many calls per second to be generated. And this is the script that is going to be used for bulk call generation. And here we can include the CWPs which we have created to be used for bulk call generation. Right now I have used CWPs from 6 to 10, 5 CWPs. So using these 5 CWPs, simultaneously 25 calls will be generated. And we are also specifying some call duration so that the calls will be placed repetitively as soon as the call gets terminated. So yeah, before moving to this one, we also provide all the statistics in this application, like all the call statistics. For example, you can see here how many outgoing and incoming calls are there, how many registration attempts have been made. Okay, until now I have placed 10 calls here. Okay, so out of those, 2 calls were failed calls. Okay, and now I'll just clear it off before generating the bulk calls. So to start the bulk call, it can also be scheduled also. Using the scheduler, or it can we can specify the time, like how many hours or minutes or days it needs to be run. Okay, and I'll just click on the start button here. Okay, so I'll go back to the statistics window. So you can see here 25 calls have been attempted. All 25 calls are active now. So the call duration was 10 seconds. So after 10 seconds, the 25 call slots are completed, and it continues to attempt the next 25 calls. So below here, we are giving a call success ratio graph. It's a pie chart. And this is the call graph where it indicates the calls per second being generated and how many simultaneous calls are there. Okay, and you can see here the calls are continuously being placed. Okay, and we'll also go back to this packet scan. Okay, so where we can see here these are the calls placed. Okay, so if you go to the end, the blue ones are the active calls here. Okay, and this is the overall call statistics here. So we can see so this is the ED137 call statistics here. It indicates the total AZ calls, GZ calls captured in the network, how many are completed, failed calls, active calls, and all. Okay, and it will also give the counters like how total PTT on and squelch on counters captured in the whole network actually. And it also gives the pilot SCT and controller pilot induced synchronous transmissions. So these are related to air to ground calls. But in general, this is the statistics window where you get all the aggregated call counters. Okay, and again here in PacketScan we do have this call graph and all where we get the complete call message flows between for this call. Okay, and again this call can also be played here. So I'll just try to play one call here. So there was no file transmitted actually. So it is the silence on the call actually. Okay. So if you go to the main window also, it lists out all the frames that have been captured, and for each and every frame it also gives the complete message decodes. So if you go to RTP frames, so it gives the complete RTP header details. Okay. So here on the summary columns, you can see here we can quickly come to know like what are the SIP methods, caller, callee, call IDs, and also the traffic details, like what is the codec used, the RTP timestamp, sequence numbers, and all. Okay. So yeah, this is all about these two products. Basically, this how we learned how we can make simulate the ground-to-ground calls, different kinds of ground-to-ground calls, and also how we can monitor these calls using the packet scan. Yeah, fine then. Everybody, I appreciate you attending this workshop. Hopefully, this has provided you some background and training on how to make use of our MAP CD137 telephone to achieve the FAA interoperability test cases. We'll send an email in a couple of days with links for both the workshops. The first one on the radio emulator, and this one on the telephone emulator. So you can have a relook at these videos, and if you have any questions, you can come back to us. You can contact us at you can send your questions at info@gl.com. It is info@gl.com. Thank you all. Goodbye.